Hey everyone, this is MD. This is part 3 of our Markov chain series. In this video, I'll be presenting a stock market problem and I will be solving it using a Markov chain model in Python. So here's our problem. The state of the stock market changes every week. Given that the current market is a stagnant market, what will the state of the market be after 2 weeks? What is the probability of the possible sequence of states occurring? And then we have a second part to our problem. Using a large sample size, what is the probability of bear market being the end state? Here's our Markov chain model, which Lewis showed us in the previous video. Again, to explain what this diagram actually is, here we have the three states: bull market, bear market, and stagnant market, and these three arrows pointing towards each of these states represent the transition from one state to the other. And the number beside each of these arrows tells the probability of this particular transition occurring. Now that we have established our Markov chain model, let's move on to our code. Here we have our code. Before running our solution, I'm going to go through what each of these variables and functions actually does. At the top, we have our NumPy library, which will be very important as we'll be dealing with random number generation. And then down here we have the states variable, which is a list that contains the names of each of these states. Then the transition name variable, which is a two-dimensional list that has the names of each of these transitions. Here A represents bull, B is bear, C is stagnant. So here, for example, AB represents the transition from bull to bear. Then we have the transition matrix variable, which is also a two-dimensional list that contains the probabilities of each of these transitions. And then moving on downwards, we have our function right here that takes weeks as a parameter. So here 2 will be our argument as we want to know the end state after 2 weeks. And then inside this function we have the market current variable, which is set to stagnant, the market sequence variable, which is a list where we will append the current market at each iteration. I is set to 0, prob is set to 1 because we already know what the current market is. And then down here we have our while loop, which will stop iterating once I is equal to the number of weeks. And then inside the while loop we have our if-else statements right here, which all relatively do the same thing. Now let's say our current market is bull, so we'll enter this if statement right here. And then what will happen is this function right here will choose a random element from this two-dimensional list right here, which is the transition name variable, and whatever element it randomly picks, it will set it equal to the change variable. Now if this change variable is equal to AA, for example, it will take the corresponding probability, which is 0.9, and it will multiply to the current probability variable. And then after that, bull will be set to the current market, and then that will be appended to the market sequence variable. Like that, as we end our first iteration, we'll add 1 to the I variable, and then down here we have our print statements. Now that we more or less know what our code does, let's run it and see what we get. So as we can see here, our market sequence turned out to be stagnant bull-bull, and the probability of the possible sequence of states is 0.225. Now to explain how we got this output, I'm gonna do a quick rundown of the code again with a visual this time. At I equal to 0, which is week 0, our current market is stagnant, as you can see from the diagram on the right. And at the first iteration, we transitioned from a stagnant market to a bull market, so our change should be equal to CA, which corresponds to 0.25. And this probability will be multiplied to the current probability. Then finally, at the second iteration, we transition from a bull to a bull market, so we need to multiply 0.9 to the probability and our loop ends. So our final probability turned out to be 0.225. Now let's do the second part of our question. This is basically asking for the probability of the end state being bear market. But this time we need to use a large sample size. So to solve this, what it is took a large sample size, like 10,000 for example. And what this for loop basically does is it iterates through all the 10,000 simulations and appends all the sequences to this variable right here. And then for the second for loop, we again iterate through all the 10,000 possible sequences, and this time when we find a sequence with bear as the end state, we add 1 to the count variable. And then finally, for the percentage variable, we have to divide the count variable by 10,000 and then multiply by 100. And then in the print statement, we print our percentage. Now let's run our code and see what we get. So as you can see here, we got 34.19% as our probability. Now if we run this code again, we got 34.01% this time, which is pretty close to the percentage we got last time. So yeah, so as we can see here, it gives us a rough estimation of what our probability could be. So yeah, that's the end of the video. Please like and comment down below if you found this video helpful. I've also attached the GitHub link to this code in the description if you'd like to play around with it. So yeah, thanks for watching.